All right, you guys, module 4.1, our first set of notes. You can find these notes that I'm looking at right here in the video in the content section of D2L under module 4. So this is 4.1. If you look at the top left-hand corner here, where I'm kind of pointing at it with the cursor, this is the name of the notes in the content area. Okay, so this is not to be done instead of your reading. You need to do the reading, and this is to help understand maybe what you read. Okay, so when we're talking about data, there's a couple of things we're looking at. First of all, we're going to look at our variables. Okay, so in math, you know that variables are things that change. That's why we call them variables. We use X and Y in an equation, but the meaning behind that is that X and Y could be any value that we input in there, right? So it's going to change. So there's different types of variables. There are qualitative variables, but these are variables that you don't use a number, okay? Gender, college year. And you guys may notice that we use gender binary in this statistics class, and I think it's just because we're using kind of like older information. This maybe not this class in particular, but I think math in particular maybe hasn't reached that point where we look at gender as not just male and female. But just to warn you, a lot of times that's what we kind of use when we're looking at data from this particular book in this particular class. So I know, and you know, that gender is not binary, but we will look at it that way sometimes in this class. So qualitative variables, things that you can't describe using numbers necessarily, and quantitative variables are variables that you can use numbers to describe. And it gives you a couple of examples here, like college year under qualitative variables could be freshman, sophomore, junior, senior. Okay, you could say year one, you could say year two, but those don't really have a lot. Those aren't really about a value so much as just a name for what year that you are in. Okay, under quantitative variables, we have two different types of ways we can use numbers to describe things. We can use discrete values, okay, which means that you are only going to have 1, 2, 3. It's not just going to be 1, 2, and 3, but what I'm trying to get at here is that it's not going to have any decimal points, nothing in between. As we move down to see what those look like in graphs, they will just be points, and you will not have a line connecting those points. And you may have talked about discrete variables in earlier math classes. So we have discrete variables, age, number of classes taken. I would say number of classes taken is most definitely a discrete variable. I might say age doesn't necessarily have to be a discrete variable, right? Like I could be 40 years and 2 months, right? I don't have to just be 40 years old. But a lot of the times in statistics, you're going to just use it as a discrete variable because it's not really going to make as much sense when you're analyzing the data to have age be a continuous variable. But under continuous variables, we have some examples such as, and this is commute time. It should be commute time, how long it takes you to drive somewhere, right? It could be 40 minutes, it could be 40 and a half minutes, it could be 25.65 minutes, right? It's not going to necessarily fit in just one number. It could be anything in between. Study time, same. Okay. So we have a table here. And hold on one second. No, I'm not going to pause this. If we were in class, what we would do is in groups, we would put some information down here. So let's say, let's just do me. Let's say my name is Rachel, which it is, okay? My college year, what year am I in college? Well, I'm not in a college year, so I'm just gonna put in A. My gender here is female, and it might not necessarily be using, you could use anything you want here for gender. It doesn't have to be male or female. My age is 42. The number of classes I'm taking is 0. I guess I could be teaching, so maybe I'll say I'm teaching 1 class right now. Well, let's just say 1. And my commute time to work is 0 minutes. This is going to be everybody's commute time. And study time will be, so let's just put, let's say how long it takes to make these videos. Let's just say 1 hour, let's 60 minutes. Okay, so we would each kind of fill this out in a group, and you would have a collection of data right there. Okay. Distribution for categorical variables. So the following table displays the result of the final exam in a class with 20 students. Okay, so we have A's. So I'm going to take just a second. I can't pause because with the way I'm recording, I'm not sure how to unpause. I think it makes 2 different videos. So bear with me as I'm kind of going through. I just want to do these in different colors here. C's, so that I can quickly count. It's easier for me to see color than to look at the letters. D's, and we'll leave F's as white there. Okay, so we're just kind of doing a little bit of review on percentages. So here it says in this distribution of categorical variables, since we can't assign a number to them, the way we describe them in a distribution is by using percentages. Okay, so what percent of students fall within each letter grade? So the first thing we need to remember about percents is percents are taken out of a whole. Our whole is going to be how many grades there are, how many students there are total. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 students. So that's going to be the denominator that we're going to use to find all of our percentages. Okay. So let's start with F's. We have 2 F's. So our percent is going to be 2 over 20, which reduces down to 1/10, right? Which is just going to be 10%. If you don't want to change the fraction to a percent in your head, you can go ahead and use your calculator, and you just, oh no, remember you guys, my calculator, I'm going to have to sign up for it. Okay, well, we will do that later, but what you can do, and it's just as easy, darn it, need to go, yes, I want to quit. I will just show you by going to the interwebs, and literally you would just type in, obviously, into your calculator, 1 divided by 10. That gives you 0.1. But remember, when you're finding a percent, you need to multiply that by 100. Okay, and it gives us 10%. 1/10 is 10%. That was for our F's. So 10% of the students received Fs. Okay, let's go to Ds. Ds are going to be, sorry you guys, I want to make this a little bit thicker. Ds are going to be it's the same. So we'll just say 10% are Ds. And Cs, how many green? 1, 2, 3, 4, 5, 6, 7, 8 is going to be 8 out of 20, which reduces down to 2/5, which I happen to know in my head should be 40%. But check with your calculator, or if my head math is wrong, please let me know that I did my head math wrong. So 3 C's are 40%, but we can also check on the end by adding up our percents, and we should get 100%, right? So B is going to be 1, 2, 3, 4, 5 out of 20, which is going to be exactly 1/4, right? So that's going to be 25%. And our A's are 3 out of 20. Did I count up everything right? 1, 2, 3, 1, 1, 2, 3, 4, 5. So our A's are going to be, I'm going to have to use the calculator for this one. 15%. Okay, so if I add all of these up, hopefully I've done everything correctly. So I get 10 and 40 is 50, and 10 is 60, 70, 85, 95, 100%. So I have found these percents correctly. So this next bullet point says, and we're just talking about what is the distribution of the data look like, and later on in the course we will start looking at this as graphs. Are the results equally divided or concentrated in one category over the other? Well, it looks like the majority are going to be C's, right? It's not equally divided. If it was equally divided, there would be 4 people who got each score, but the majority of people got C's, and then the second would be B's. So if it was well, I'm not going to get into that right now. What you will look at kind of is if it was a circle, okay? And this is just going to be rough. If this was 50%, let's say that's 40%, this would be the C's, 10% there, 10% there. You see where I'm going with this. It would be distributed like that. Not all of the pie pieces would be the same size. Okay, it is not evenly distributed. Okay, frequency. A frequency has your definition right there, is a count of a category that refers to the number of observations in each category. Frequency distribution for a qualitative variable is a listing of all of the values of that variable can take together with the frequencies for each value. And then we get into relative frequency is divided by the sample size. This is exactly what we just did, okay? So you don't even have to worry about this. This is exactly what we just did. We would put, I can't remember what they all were, but I think like C was 8, and then this was 8 divided by 20, which was 40%. Okay, so this is exactly what we just did above, but I didn't see they had this beautiful little table for you to do it in. These were both 2, right? And then it was 10%. And B's were, let's see, B's were 5 and A's were 3. And that was 15% and 25%. Okay. Oh, and look, it made us our little pie chart anyway. Well, you guys, I wish I would have seen this page before I just did all of that. But you can see our pie chart is beautiful and much better than the one I drew, the stick figure one I drew above. All right. If we would have drawn it as a bar graph, and this is an important, I want you to realize that here, this is what it's talking about. These numbers represent the frequency, okay, this side, or how often it occurs, and you can see why that's how high they go up, how high the bars go up. So the red would be frequency, and the blue would be the relative frequency, or as a percent, okay? It looks similar, right? But obviously the difference between 40 and 25%, that's going to be on that graph, 15 spaces, whereas between 5 and 8, that's only going to be 3 spaces, but you get the gist of what it looks like. Okay, now we get into quantitative variables. Okay, and before I get any farther, I'm going to go down and see what they've done. Okay. So we just talked about how we take our qualitative variables, which are variables that you can't use really a number to describe, and how we turn it into numbers by using frequencies and percentages. But for quantitative variables, we actually have numbers, okay? So the following table displays the result of the final exam with 20 students. But these are actual numbers for their grades as opposed to just their letter grade, okay? So what they've done is they have put them into intervals, okay? And this way we can make histograms by using intervals. I think in 6th grade you might have learned them as bends, but either way, when you're building your histogram, you need to use intervals. You're not going to put everything like above all of the A's go in A when you're using that qualitative variable data and you're building a bar graph, but when you're building a histogram with actual quantitative data, you're going to have intervals. Okay, so here is your count, or how often it happens. So what this is saying, and let me switch colors here. What this is saying is that if we're looking to, and remember, we're going to have a little mini history lesson here. A square bracket means that it can be that number. So if there is a 50, it will go into this interval, 50 to 60. But if it's actually 60, it will go into the next interval because the 60 has that kind of round parenthesis as opposed to the square parenthesis. You may also hear these talked about as closed and open parentheses. So there's an open parenthesis next to the 60 and a closed parenthesis next to the 50. But either way, it's saying there's 2 values that fall in between 50 and 60. So there's one here, this 50, and where's the other one? Oh, and 52. Okay. And then it goes on to do this work kind of for you. I will do one more example. Let's say it could be 60 all the way up to, but not including 70. And it says there's 2 of those. So that's going to be, it looks like here, 62 and 68. Pop quiz, where is this 80 going to go? Is it going to go here or here? If you said The second one, you are correct. It is going to go into the 80 that is next to the square bracket. Okay. Oh, look, pop quiz right below. It already has that information for you. Please feel free to read through that if you did not get that information from what I was saying. Even though I'll take a moment right here to just let you know, even though I am not going to make you turn in any notes that you do, please take them. So you will have them near and dear to your heart in a notebook or a spiral, or however you want to have easy access to these notes, so that when you are doing your homework or your test reviews, you have them right there. All right, so taking that table and turning it into a histogram. So one important thing I think students don't realize about histograms, the difference between a histogram and a bar graph, is histograms, because they use intervals, they do not have spaces, okay? They don't have spaces in between their bars. Like a bar graph, remember our A's, they had that space in between it. Let's see if we can go back up there. Where's our bar graph? Here. So these bars in the bar graph had spaces in between them. When we talk about histograms, our histograms don't have spaces in between them, okay? And that's because our intervals go right up to that next number, okay? So we're still using the frequency, is how many numbers fall into those intervals. Okay, a frequency is a count of something. And then a stem and leaf plot. And I will say, I believe there was a question that had all of this information on the final. On the final that I just gave for the spring semester, it had all of these on there. So I haven't seen the final for the summer. It's definitely not the same test, but I believe it'll have all of this stuff in there, including the histogram and the stem and leaf plot. Okay, so the stem and leaf plot, what we do is we take, in this case, the 10ths value. So the 5 from the 50, the 6 from the 60, the 7 from the 70, the 8 from the 80, the 9 from the 90, okay? And then you put the 1 place here. So we have a 50, so we put a 0, and we had a 52. We had a 68, and we had a 62. So this is a really quick way that you can kind of analyze your data if you're given a string of numbers, just like that in that box, okay? The only difference from the left side to the right side is that they put the ones in order. So here the 0 and the 2 are already in order, but here we have the 60 and we switched it around, so the 2 came first and then the 8. And that's because if you were literally writing these numbers in order to find the mean, in order to find the median, you would have to write them in numerical order. So 50 would come before 52. So that's why you write it like this. And 62 would come before 68. So it's basically just a really quick way to write everything in order, so that when you're counting to find your median, it makes it really easy, because you could just say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that means the median is going to be right here between the 6 and the 7. So the median of these numbers, which we will get into in our next video, but you should remember this. The median is the number exactly in the middle. If it falls in between two numbers, right, there's 10 on each side. If there's 20 numbers, it's just going to be right in the middle of those two numbers. So it's just going to be 76.5. But that's the reason why they changed them to be, if they come out and not correct numerical order. We just changed them to be in numerical order so we can count that up really quickly. All right, you guys, this was the end of the 4.1 video. I hope you enjoyed this first video, and don't forget, you can ask me any questions that you have over this during our meeting time.